Do you wonder where your next glass of water will come from? While many people today leave that to water experts, the truth is that a huge water crisis that can send all of us thirsty is brewing. The solution for many countries is desalination, but this process is severely hampered because of some limitations. However, a group of brilliant scientists have come up with a solution. They have found a new way to turn salt water into fresh water, which we bring you in this video. Water is life, which is why a global water crisis is something to be dreaded. Many industrial processes depend on water, but your throat also needs its water daily. However, we simply can't run away from the fact that we are staring down the face of a global water crisis. Before we dive into the new solution for turning salt water into fresh water, just how severe is the global water crisis? Water is supposed to be abundant as it covers 70% of planet Earth. However, out of all that water, only 3% is fresh. That is the type of water you drink, bathe, and irrigate farmlands with. And that is not even all. More than 2/3 of that tiny freshwater amount is locked up in frozen glaciers or otherwise not accessible to humans. About 1.1 billion people globally did not have access to water. However, if you include the part of the population that finds water scarce for at least 1 month of the year, the total jumps to 2.7 billion. The health effect of lack of water is staggering. Inadequate sanitation affects 2.4 billion people, exposing them to diseases like cholera, typhoid, and other waterborne illnesses. In fact, 2 million people die each year from diarrheal diseases alone. Many water systems that keep ecosystems thriving and feed a growing human population have become stressed. Rivers, lakes, and aquifers are drying up or becoming too polluted to use at the current consumption rate. This situation will only get worse. By 2025, 2/3 of the world's population may face water shortages. So what and who is responsible for the global water shortage? Is it people drinking too much water or flushing the toilet one too many times? While it's great to use water responsibly, the fact is that most of our fresh water supply goes into agriculture. About 70% of our drinkable water goes to farming, and 60% of that supply gets wasted due to leakage into inefficient irrigation methods. To fix this crisis in freshwater supply, some countries have resorted to desalination or turning salt water into fresh water. How does this process work? There are several preliminary steps like pumping in the seawater and pre-treatment, but the main step is reverse osmosis, where the salt comes out of the water. Here, the water is forced through a series of very thin membranes with roughly atom-sized holes in them at very high pressure. Water molecules go through these membranes while salt remains on the other side. The principle is the osmosis you might have learned about in high school biology class. It says if there's a membrane between two water solutions, particles from the more highly concentrated solution will move across the membrane to tell less concentrated liquid left to its own devices. This is what the water is going to do, but desalination does not leave the water alone because it tries to reverse osmosis, and because it's working against the chemical inclinations of the water desalination, it needs energy and pressure to work. The reverse osmosis membranes are usually made from a combination of polymers. The critical polymer is usually a substance called polyamide. The polyamide is a microscopically thin, like 0.2 of a micron thin, or about the thickness of bacteria. Then it was an overhanging polymer called polysulfide, which is 40 microns thick and is joined by a polyester fabric, which is 120 microns. Adding together all these thicknesses, you still only have 1/8 of a millimeter. While simply in theory, desalination has major drawbacks as a method for getting fresh water, these membranes are expensive. To put that into context, a desalination plant could cost $500 million. So these membranes could cost $50 million. These membranes may last between 7 and 10 years. So you will spend 10% of the whole cost of the plant every 7 or 10 years. The membranes also need constant care to avoid getting fouled up. Also, the side effects of desalination on the environment, for example, in 2019, desalination plants pumped out 142 million cubic meters or 5 billion cubic feet while producing 95 million cubic meters of fresh water.